Okay, the first question says discuss the symmetry of the function and justify your answer in function notation. Okay, so when we first learned this, we did it like this. If it had symmetry about the y-axis, then your x's right here would give you the same y, right? Yeah, you can look at the board or my screen, whatever. Your x's will give you the same y right here. Okay, so that's the y right here. Hold on. So that's symmetry about the y-axis. So y-axis right here. Oops.
Wait, you can make.
Okay. There's also symmetry about the x-axis. That is when you have a graph that looks like this one. Okay. I mean, it could be curved too. I just want to do.
Wait, did it say justify answer in function notation?
Yes, in function notation. Now this is not in function notation, but I just want to kind of review this really fast. So this x right here will give us this y, and it'll give us a negative y. So this x would give you both the positive and the negative y. Alright, so let me get rid of that. I'll write the function notation in a minute here. Okay, and then the last one is about the origin. If it has symmetry about the origin, it looks something like this. So that like if you had a point right here that was xy, you get the same x but negative x will give you the same y but the negative y. Okay, so xy would, if you plug in x you get y, and if you plug in negative x you would get negative y. Over here, if you plug in x, you can get a positive y or you can get a negative y. So that's about the x-axis. And then the last one is if you plug in a positive x, you get the y. And if you plug in a negative x, you still get the positive y. So those are all the symmetries. I know it sounds looks kind of crazy. So let me show it to you guys in function notation.
Can you just tell us which ones?
So to be the x, to have symmetry about the x-axis, to write that in function notation, it would look like this. You would plug in f of x would be the same as f of negative x. For the y-axis, it would be f of x also equals negative f of x. So it doesn't matter if you plug in a positive x, you can get the negative or the positive version of it. And finally, the last one, for the origin, if you plug in x, then you get a positive f of x, and if you plug in negative x, you would get a negative f of x. So that's how you describe the symmetries in function notation. But for our graph right here, what you have to do is think about, okay, how does that look on a graph? Like if it was a regular sine function, it would look like this. Does that have symmetry about the y-axis?
No, yes.
No, the y-axis is right here. If I fold it right there, the lines won't match up. But if I take that line, if I take the sine line and I move it over so that it looks like the cosine line, does it have symmetry about the y-axis? If I fold it, would it match up? Would it line up? It would, wouldn't it? Yeah. So if this function has been shifted, then it would have symmetry, right? Now there's also the case of the origin. So like if I look at the sine function without it being shifted, here's the sine function with no shift. Is there symmetry about the origin? Like if I plug in this x, I get this y, right? Which is right here. If I plug in that same number but the opposite, do I get the negative y? Yes, I do. So does that have symmetry about the origin? Yes, that one does. Okay. We can also look at the tangent function, but let's just look at the sine right now. So there is symmetry here. Okay, because this graph hasn't been shifted. There's no phase shift. It's just been stretched, and the period has scrunched the graph. Okay, so there's going to be symmetry here. And actually, you would say there's symmetry about the origin. So this would be the answer right here. You can say there's symmetry about the origin. Okay, and that's what you would write. Okay, so now let's do the rest of it. So for this next one right here, it says solve it. So what you have to do is get the sine alone, so then you can get the x. So let's get the sine alone first. We divide it by 3 to get rid of the 3. 0 divided by 3 is 0, so we have sine of x divided by 2 equals 0. Now, let's pretend this is not here. Sine of an angle equals 0. What angles are those?
0.
0. Sine of 0 equals 0, and what else?
Sine of 2 pi.
Sine of 2 pi works, and sine of pi. Now, I'm not going to say 2 pi just because it's the same as 0, right? Okay, so let's reveal that again. That angle has to equal 0, or that angle has to equal pi. Now remember, I'm not saying 2 pi because that's the same as 0. Okay, so now when I solve here, this would be x equals 0, and x equals what? 2 pi. Now that's what actually x equals in order to get 0 and pi. Okay, so now
we have to use general term.
Now this one, it doesn't give us an interval, so we have to have it in general form. So we have 0 plus, and then we have the period times n. What's the period for this one? Well, because it's being divided by 2, it's the same as being multiplied by 1/2. You take the normal period and divide it by 1/2. Multiply by the reciprocal, we're going to get 4 pi. Okay, then the other one is 2 pi, and we're adding 4 pi in for that one. So these are the answers right here. Okay, yes, I would give a point for that, but this would give you full credit. Okay, now look at the next one. It gives us the same equation, except this time it gives us a little interval.
Then you can just take the answer from the other one.
Yeah, so look at this interval and look at the answers that we got before. Are those in that interval? The 0 is, right? Is the 2 pi in the interval?
Yeah.
What does a parenthesis mean on an interval notation?
Not included.
It means it's not included. So we don't care about the 2 pi, even though it is a solution, right, if we looked at the whole thing. So yeah, it's kind of sneaky. Alright, so now we just have to graph it. This one says use your answers from A, B, and C to graph. That kind of helps. Let's see. What do we get from A? Well, A is that there's symmetry. Okay, we'll use that. B gives us the x-intercepts because see how it's set equal to 0 right here? That means if you solve it, you're going to find the x-intercepts. So our x-intercepts were at 0 and 2 pi, which means over here, using symmetry, that's going to be an x-intercept also. Now we know that the 3 does something to our graph. What does the 3 do?
Amplitude.
Amplitude. It stretches it out. Okay, so if I go to the middle, this is 2 pi. What's this one going to be? That one's going to be pi. Now is this going to go up or is it going to go down? It's going to go up right here. So we're going to go up to 3, and then back down right there, and then we use the symmetry idea to copy to the other side. Alright, that's your graph.